Hello and welcome back. In this video we'll be looking at the next homework assignment, which is on units. We'll start looking at units. When we want to describe something physically using numbers, units are very important. So for instance, there's a big difference between 10 feet, 10 inches, and 10 meters. 10 meters being super long, 10 inches being less than 1 foot. If I gave my weight in pounds versus kilograms, I'd be giving two different numbers. So knowing which one is which, knowing if I say, oh, I'm 10 tall, well, 10 what? 10 inches is very different from 10 feet. So units are very important. And the first thing that we'll do is we'll look at units that describe length versus area versus volume. Again, just to reiterate, the length of something is just going to be, how long it is, how far it would take to get from one point to another. Area is when we have some sort of flat shape, and it's going to be the, how much space does that shape take up. And then volume is going to be if we have a three-dimensional shape, if we have a box or a sphere like a ball or anything like this. What's the physical space that it occupies? And what we'll do is we'll compare a few of these. So most of us will be aware that there's 12 inches in 1 foot. So if I draw something that would represent 1 foot, 12 inches, well, we'd have to fit 12 of them in here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, let's put another one there. So that would be 12 inches. So each of the small things would be an inch, and then the long thing would be a foot. So it's 12 inches in 1 foot. Now, the thing is, if we were talking about area, so for instance, if we were to look at a square, and let's imagine that this is going to be 1 foot on a side. So if we want to know how big the square is, what is the area of the square? Well, it'll be 1 foot times 1 foot. And 1 foot times itself, well, that's just it's squared. And 1 times 1 will be 1. So this is going to be 1 square foot. But if we think about this in terms of inches, well, now we've got all of our inches. I probably won't do this very accurately, but we've got all of our inches on this side. We've got all of our inches on this side, and if we start dividing this up, we can see that there are a lot of square inches in here. And without wanting to draw all these lines and count them all, there should be an easier way to see, well, how many square inches are going to be in here. And again, we'll just do the same thing. If we know that we have 12 inches on a side and 12 inches on a side, the area in here is going to be 12 inches times 12 inches. Well, 12 times 12 is going to be 144 inches squared. So even though there are 12 inches in 1 foot, if we're talking about 1 square foot, there are going to be 144 square inches in there. Again, all we're doing is we're squaring numbers. If we take 12 times 12, I get 144. Let's do another one. Let's say that we're going to look at volume now. So again, 100 centimeters is going to be 1 meter. So if I draw 1 meter, there will be 100 centimeters in here, and they'll be too small and I won't be able to draw them. So something that is 1 meter long is also 100 centimeters long. 1 centimeter being 1/100th of a meter. But if I look at, let's say, a cube that is 1 meter by 1 meter by 1 meter, the volume here, the volume of a cube is just going to be 1 meter to the third power. I'm going to take 1 meter times 1 meter times 1 meter. Cubes are very, very nice to find the volume of. It's just you take your three lengths and you multiply them together. But we can do the same thing with centimeters. 1 meter cubed should be the same as 100 centimeters cubed. And again, 1 meter cubed, well, 1 times 1 times 1, well, that's just 1. It's pretty easy. 100 times itself 3 times. We could whip out a calculator. 100 times itself 3 times is going to be 1,000,000. And if we count these up, that is 1 million centimeters cubed. So again, we could divide all this up into all these little centimeters, going up, going down, going backwards. And if we were to divide this up into little cubes that were all 1 centimeter by 1 centimeter by 1 centimeter, there would be 1 million of them in there. And it's as simple as just taking 100 and raising it to the 3rd power. There's nothing more complicated than that. Even if we use measurements that we're not as familiar with, for instance, there's 320 rods per mile. Again, this is not something that I'm super familiar with, but in 1 mile, there's going to be 320 rods. It's an older measurement when people would actually use a rod, like just a big metal stick, to try to measure something. And again, there'd be 320 of them. Well, that's too many to draw on there. But let's imagine that I have a piece of land that's 1 mile by 1 mile, often called a section. So then if I had 320 rods going this way and 320 rods going this way, how many squares that are 1 rod by 1 rod would I have in here? Well, again, if I'm talking about squares, I'm going to square things. So 1 mile squared should be the same thing as 320 rods by 320 rods. So we'll square that. And then here, 1 squared, well, that's just going to be 1 mile, 1 square mile. 320 rods, maybe that's a little bit hard to do in my head, so I'll take 320 and I will square it using decimals. Enter, I'll get 102,400. So this is 102,400 square rods. So again, these don't even have to be measurements that we're familiar with. Maybe some of you haven't even heard of rods before, but it all works exactly the same. If we're talking about area, we're going to square things, and 320 squares is going to be 102,400. So that's how many square rods there are in 1 square mile. The next little bit, we're going to be looking at the word per. And you may remember this from percent as well. And to find a percent, we divide it by 100. Cent meaning 100. The per is what means division. And we can take a look at a couple of examples and see where this comes up. So let's imagine we drive 50 miles and we use 2 gallons of gas. So the question is, how many miles did we drive per gallon? Well, some of you may have been able to do this in your head, and you see that we got 25 miles per gallon. But how did we do that? Well, the way we think about this is if we want miles per gallon, what we want are miles divided by gallons. And again, we drove 50 miles, and we're dividing it by 2 gallons. And what we do is the units, if we're dividing miles and gallons, we are going to get the units that are miles per gallon. And then the rest of the numbers, we just do this operation. So here we have 50 divided by 2, which is going to be 25. And miles per gallon is often abbreviated MPG, so we could also write this 25 MPG. But again, per just means divide. So that's all there is to it. So here, a can of Coke weighs 369 grams. So G is usually the abbreviation for gram, and is 355 milliliters big. So this is how much space it occupies. So the question is, what is the density of Coke in grams per milliliter? So grams per milliliter, we know what this means. This means that we're going to take grams and we're going to divide it by milliliters. So again, we have 369 grams and we're dividing by 355 milliliters. This is not something I can do in my head, so let's come back to our calculator. And we'll take 369 grams divided by 355 milliliters. And if I round to the nearest thousandths, so that's 3 decimal places, so 1.039. Do I round the 9 up? No, because 4 is less than 5. So 1.039. And again, if I'm just dividing numbers, I could write that, but this is 1.039 what? And here it's going to be grams per milliliter. And oftentimes with something like this, we can actually leave this as a fraction. We can leave the units as a fraction. So depending on what class you're taking, what textbook you're reading, you might see something like grams per milliliter. And they'll leave it written as division. So it's even easier to see what it is we're doing. We're dividing because we've got a fraction. We've got G divided by milliliters. So let's do one more example. And in this example, I tried to use units that maybe we're not even familiar with. So over the course of a day, which is 24 hours, a refrigerator can use 3,000 joules of energy. So what is a joule of energy? It's just a unit. It's just describing an amount of energy. Does it matter what it is? Well, no, because what we're asked to do is what is the power of the refrigerator in joules per hour. So even without necessarily understanding what joules are, we can see joules per hour. Oh, we should be finding joules divided by hours. And there's not a whole lot more to it. We know that what we're trying to find is joules per hour. We use 3,000 joules in one day, which is 24 hours. And that's it. All I need to do now is plug this into my calculator, and I can take 3,000 divided by 24, so there's 3,000 joules divided by 24 hours, and we get 125. So this is going to be 125 joules per hour. And again, we can write this in some contexts. We can write this as 125 joules, which is normally just a J, per hour. So again, either one of these will work, and ultimately, it doesn't really matter what joules are, or even what hours are. I'm sure we understand what an hour is. What's important is just understanding that per means divide. And that's it. So good luck on this homework. If you have questions, reach out to me. Please let me know if you need extra help. This is what I'm here for.